We are going to review some concepts that we've already gone over before, so nothing new here, but you're going to be taking the notes as we go, and you'll be able to use these notes when you take your final exam. So you should be copying down on your notes what I'm putting on to mine. So we're going to start with rational and irrational numbers. So a rational number, I can express it as a fraction. It could be a repeating or a terminating or an ending decimal, and a square root of a perfect square. Those are all perfectly acceptable and consider themselves as rationals. So if we can express it as a ratio, so all of our integers work that way. So I could have positive 5, that works as rational. I could have a negative 2, that also works as rational. If I look at my decimals, so if I have something that has something after my decimal, both of these have decimals. If I look at repeating, so I might say, let's see, 3.725. And if I put a line over that 5, that's now repeating. So that counts as rational. Or I could have 15.6. Since that ends, it's terminating. That is also rational. Anything that can be written as a fraction. So if I have 1/4, that's a fraction. That is also rational. And a perfect square. So I might say square root of 25, which is just 5. So that's rational also. So examples of rational numbers. Irrational numbers, you cannot express them as a fraction. The decimals don't repeat, or they don't, and they don't end. They don't do either. And the square root is kind of something gross, right? So our typical numbers that we see as irrational, let's say I have a square root of 6. That's not very pretty, so that is irrational. If I have pi is our classic example of irrational numbers. And let's say I have a decimal 3.217 ... That ... tells me that it keeps going, but there's no repeating here. There's no line on the top, so I don't see any pattern to it. So that is also irrational. Okay, so you want to make sure you have all that written down on your notes. Pause if you need to. Make sure that you have those copied down. All right, next we're going to look at our power rules. This is exactly the same cheat sheet we used when we took the quiz. So again, nothing new here. I'm going to go through it pretty quickly. We've done our power rules relatively recently, so this should still be pretty fresh for you. So our product rule, we're going to add the exponents. So if I have a to the second times a to the fourth, I'm going to keep the base, add the exponents. Oh my God. Sorry, y'all. That was my cat. My cat just knocked things off the thing there. Off you go. All right, back to our power rules. Power of a power. So if I have b to the third power, and that's all to the fifth power, I get b to the 15th. So this is where we multiply, because I get my 5 is kind of floating. It doesn't really have a base that it's belonging to. Power of a product. So inside my parentheses, I have kind of 2 pieces to that, right? So I want to think about this kind of like it's the distributive property. So I'm going to do 2 to the 4th, and I could do the math for that one. And then I'm going to have c to the, this is where we multiply, so c to the 8th. Our quotient rule, I've got a fraction. So let's say I've got d to the 6th over d to the 2nd. So I can subtract those exponents, but I always put the base in the numerator. So if I'm going to use that fancy subtracting trick, it has to go in the numerator. And I don't really need to write that over 1, so just d to the 4th. Negative exponents. So let's say I have x to the negative 5th. I can think about that like it's in my numerator. So I'm going to write this as a fraction, but I'm going to move the base to the denominator and make that a positive exponent. So that's x to the positive 5th, and there's a 1 in my numerator. I need to keep that one, otherwise this x to the 5th doesn't look like it's in the numerator. It doesn't look like it's in the denominator. And our last one, this is the one that's pretty straightforward. Anything to the 0 power is always equal to 1. Okay, so make sure you have those examples written on your notes. Again, you'll be able to use these on your final. So you'll want to be able to refer to these. All right, next, let's go to the back side of this. We have our formulas. We just did our formulas quiz, so these should still be pretty fresh for you. So our sphere, our volume equals 4/3 pi r cubed. Make sure you've got that as cubed there. Sphere is the only one that's got a cube to it. Our cone, V equals 1/3 pi r squared h. All right, so this is back to our squared there because a cone has a base that is a circle. And our cylinder, we've got our straightforward pi r squared h. That's our cylinder formula. And our last formula, our Pythagorean theorem. Don't forget that when I'm trying to find the hypotenuse, it is the one that is across from the right angle. And our Pythagorean theorem, a squared plus b squared equals c squared. Don't forget that we're squaring those. That's an easy mistake to make. Put your hypotenuse in to your formula first. Make sure that's in there. All right, make sure you have those formulas copied down. And then last but not least, we're going to come back to our scientific notation, which again we looked at when we were looking at our MCAS. You want to be able to move numbers back and forth from scientific notation. So scientific notation, we're writing really small or really large numbers. What does it look like? We've got a coefficient in the front, and it has to be greater than or equal to 1, but less than 10. So 4.5 is in between 1 and 10. The base, so times a base, the base is always 10, so it's always times 10 to the something. And then our exponent, if that exponent is positive, we're talking about a large number. And if our exponent is negative, that's when we're talking about a small number. And when I say it's small, it's less than 1. All right, let's take a couple of these and actually convert them from scientific to standard notation. So 4.52 times 10 to the 5th. This 10 to the 5th tells me this is a large number. It's going to be larger than 1, so it's going to be, I'm going to move my decimal to the right for this one. So I'm going to put my 452 kind of to the left there. And I want to move my decimal 5 places. So 1, 2, 3, 4, 5. And I'm going to fill in that space with zeros. So 452,000, right? My decimal goes at the back. My next one, I've got a negative exponent. So this number is going to be less than 1 when I'm done. It's going to be small. So I know I'm going to be moving my decimal to the left. So I'm going to put my 2, 3, 4, 1 kind of tucked over here on the right. And I'm going to move my decimal 5 places to the right, to the left. 2, 3, 4, 5. There's going to be my decimal. So I need to put 1, 2, 3, 4 zeros in there to hold that decimal in its spot. And these last two, we're going to take these numbers that are in standard notation and rewrite them so they're in scientific notation. So I want to start by making sure I have that number in front between 1 and 10. So I'm going to put my decimal point here between the 4 and the 5. That gives me 4.5, which is between 1 and 10. So 4.568 times 10. Now this number is bigger than 1. This is a large number. So I'm going to have a positive exponent. And I had to move my decimal, here it is right here, 1, 2, 3, 4, 5, 6. So 10 to the 6th power. And then this last one, again, I'm going to try to put the decimal so I have a number between 1 and 10. So I'm going to put it here between the 9 and the 7. So 9.7823 times 10 to the, and now since this number is small, I have a negative exponent. This is less than 1, so it's going to be negative something or other. 1, 2, 3. So a negative 3. That'll give me a number that's less than 1. All right, you should have all of that written down on your notes at this point. And now you are going to use these to get some practice in.